Mm. So, in fact, what I'm going to try to get you to do is to create some slices with the cube, some of which are going to be kind of easy. So let's get started. Let's start. Hi, Samantha. I was trying to convince people to turn their camera on to their cube and rubber band like I've done here. Asima did it for a second.
I can't read what's on the screen when I'm pointing it at my Rubiks Cube.
Yeah, so I will temporarily turn on the screen just to read some of the questions. Then I'll turn off the screen and so that we can share. Some of these first things are we're trying to build a square, a rectangle, a triangle. And then I've got several different types of triangles, which we may or may not know the definitions of these. If so, we'll go through and I'll draw some pictures. And so, but let's just first try to get a square, a rectangle, and a triangle. I'll turn off the share so that it's easier to find. So Naomi's trying to find her cube. If you've got an apple or a potato and a knife, you can make one, as I did in the first session. If not, dig through, and when you find it, you can show off your cube chops. But my daughter calls that dad humor. So when we're slicing a cube for a cube chops, can anybody show where to slice a cube? Karate chop. That'll give us a slice that looks like a square. So you can just put a rubber band around to give us a square. Sure. I mean, this is Ashima's got it. I mean, this is very much the definition of a cube. Is it's a square prism, which means that it's a square in one direction. If you look at the base, if you look at the very bottom of the cube, that's a square, and then you just stretch it up and down. So if you slice it in a horizontal or vertical direction, you get a perfect square. So that one didn't surprise anybody. What about a rectangle? Can you figure out a way to slice it to make a rectangle? You might have to hold the rubber band on with your fingers. It doesn't stay on by itself. Looks like you put it in the slits in the cube, but in fact, the slits can sort of hold it. Actually, this is a slightly cheap question. Is right here, I've got a square. What is the definition of a rectangle? Can anybody tell me the definition of a rectangle? Well, in fact, adjust my stuff a little bit.
Four.
For what?
Say it loud.
You can also put it in the chat as an option that works. Whoops, what did I do? I did something and the Zoom disappeared. Okay. So a quadrilateral, a rectangle is a type of quadrilateral, but that's not the definition of a rectangle. A figure with 4 straight sides and 4 right angles. Naomi nailed it. I like that definition. And so a figure with 4 straight sides is a quadrilateral. Just to be clear with what a right angle is, I don't know why it's wanted that up there. But a right angle actually, I'm going to switch fonts a little bit because I know that my handwriting is pretty much illegible even when I do it. A right angle is you draw an angle like that, and you ask, is this angle the same as that angle? And meaning congruent, meaning you can get one to the other. In fact, like we had the reflections yesterday in the Khajiit, a reflection is a rigid motion, and that takes this angle to this angle. So a right angle is equal to an angle congruent to its supplement. So I need to say what a supplement is. Here's an angle. This, if I make a straight line and I put 2 angles on it, this is the supplement.
You're not sharing your screen. We can't see.
Absent-minded professor, huh? Thanks for shouting that out to me. So here's what I was writing on the screen. I was giving some definitions. So to have a right angle, I make an angle between a ray and a line, and I ask, is this angle the same as this? So if this is the angle over here on the right side with just one little arc, over here on the other side where these 2 angles make a straight line, it's called the supplement. The terminology is not that important. And so say that 2 things are the same means you can move one to the other. If we reflect across this line, this angle switches into its supplement. So these are called right angles. And a rectangle is just as Naomi said, is 4 straight sides and 4 right angles. So is a square a rectangle by this definition? Does this have 4 straight sides? And does it have 4 right angles?
Yes.
Yes. So a square is a rectangle. So that meant that if I stop my screen share and go back to my camera, we in fact didn't have to do anything in order to build a rectangle. But a more interesting question is, could you make a rectangle that's not a square? And I think Ashima put her rubber band so that it was a little hard to see, in kind of the sides, in part along the line of the cube and here. So then, because the cube, the top of the cube makes a right angle to the side, when you look at this, the angle between these 2 stretches of the rubber band are 90 degrees. This angle is 90 degrees. Each of these are 90 degrees. All of the sides are straight because it's where a cut with a straight plane is going through a cube which has straight faces. And so that exactly is fitting the definition of a rectangle. In fact, this is not a square because the sides of the rectangle are not congruent. This side is shorter than this side. In fact, by cutting 2 sides that are adjacent on the cube with the rectangle, we can get many different rectangles. In fact, we can get rectangles of, in fact, all aspect ratios. So any rectangle is going to be similar because we can get one with, oh, that's bad, with a really small side compared to the length here. And this could get as small as we like, or it can go all the way up to the place that's in the middle, where you get it out to the stage where it's a square. And then you could even change the aspect ratio. In fact, a different way to get a rectangle is if we took it on the 2 opposite sides and we just stretched it over like that, then this side, because it's at an angle, will be longer than this side here. If you had 2 cubes, which you do have 2 cubes, you have the test cube and you have the regular Rubik's Cube and 2 rubber bands, you could put them together and compare. In fact, in our list of shapes, I can write down I'm going to have to share here. A square is equal to a rectangle with all congruent sides. So this is a rectangle because it's got 4 straight sides and 4 right angles, but it's not a square because this side and this side have different lengths. The purple side is shorter than the red square. In our list, we also had a triangle. Can somebody, I'll turn off my screen share here. Where did we go? Let me right there. Oh, did I not share my screen again? Let me go back and share for a second. So here's what I wrote. I wrote a square is a rectangle with all congruent sides. And then after I wrote that, I gave this example of a rectangle that was not a square. It was a rectangle because its sides were straight and it had right angles, full right angles. But this side was shorter than this side, so there was no way to move the red side, so it exactly lined up with the purple side. Now I'll stop the share. And can somebody show me a triangle on their cube with the rubber band? Looks like Ashima has brothers, sisters, friends. Welcome whoever's in Ashima's video. We're glad to have you. If you want to introduce yourself, we'd be, maybe you didn't want to do that, but if somebody want to, that's a way to hide, is to show your cube. So how do we make a triangle? Good morning, Ace. Welcome. Nina and Sam. Welcome, Nina and Sam. We're very glad you're here. Well, I'm trying to encourage somebody. So, somehow there's things that are different for our kids versus adults. With kids, it's almost like slave labor. We say, hey, you're going to go to school and you're going to do homework. And we say so. Oh, awesome. I like it. We've got a triangle. Yeah, so if you just stick it over sort of one of the corners like that, that's a triangle. So what's a triangle? Well, it's just three angles. That's what it means. It's, three straight sides and three angles. We've got different types of triangles. In fact, one of the types of triangles is we talked about a right angle. A right angle is like this angle here, where this angle is equal to its supplement, because this angle is the same as this, so those are a right angle. A right triangle would be a triangle where one of the angles in the triangle was a right angle. So a variation on the triangle question was, could you make a right triangle by slicing the cube? And that's a little tricky. So here we can make a triangle by cutting the cube in a place where it cuts three edges that meet at one point. Is it possible to make a triangle by cutting edges that don't meet at a point? So is this the only way to make a triangle? Just like when we had a rectangle, we had two ways to make a rectangle. I could make a rectangle by cutting two faces that met along an edge like this, but I could also make a rectangle by cutting two opposite faces. So what do you think? Can you make a triangle by cutting three edges that don't just meet at a corner? So I'll pause and make an announcement. I'll do a screen share and show. So I was starting to sort of blather about, hey, it's unfair. We make kids do all these things like school and math camp, and just because we say so and we're parents and we can do that. when adults are sort of not made to do things, that's work. And well, at least the adults get paid when they go to their job. Well, we are trying to encourage you to do things. And so we have a way to get a little bit of payment for our math camp students. So this is one of our announcements. I'm doing a screen share. So on the screen share, there's some sessions. We've had a numbers of sessions where we've done some problems, but not all of them. Like the logic problem puzzle from the beginning of the camp. Well, we gave these two Sudoku problems where you're supposed to fill in these grids with the numbers 1 through 9 so that the numbers 1 through 9 are used exactly once in each row and column and exactly once in each of the square cells of sort of the tic-tac-toe board. If any of these puzzles, so here's 2 Sudokus, or here there's a puzzle where can you find the pattern and fill in what the pattern needs to be, or here's a count how many squares you need to see. I'll show you some more puzzles. Any of the puzzles that we don't solve in the videos, if you solve and snap a picture and send it to us, we'll send you a $15 Amazon card that you can use. If you solve 2, we'll send you 2 $15 Amazon cards. We can do that up to a limit. We probably can't do it if you solved 100 of our puzzles. We've got some tiling problems here that Gabriella gave. So here, how many pentominoes are there? And then she showed a picture of all 12 pentominoes. So that's not so interesting. We could ask about how many hexaominoes are there. In other words, put 6 squares together where in a tile, every square shares an edge with at least one other tile. If you can show me all of those or tell me how many there are, that's worth a gift card. That's a kind of big thing. If we want to go to, there's a way to make things that are like pentominoes, but instead of with square cells, with hexagonal squares. If you show me the number of hexagonal pentominoes that there are, that's worth a gift card. What rectangles can you make? There's certainly the standard rectangle in the picture in Polypad, which I think she gave a link here to Polypad. If you find a different rectangle made out of pentominoes, that's worth the gift card. Here are 3 5x5 squares. If you find another 5x5 square, that's worth a gift card. If you take a 5x5 square and fill it in with numbers using the Sudoku rules, where each cell uses the numbers 1 through 5, and each row and column uses the numbers 1 through 5, that's worth a gift card. So there are ways for you to earn gift cards. I am forgetting, I'll send this in an email. There may be some other puzzles that we've posted here. I think there might be some in the die games of Gabriella. So I'll stop the screen share because that's the less interesting stuff. So oh yeah, Rubiks Cube, by the way, that's another thing. If you scramble your Rubiks Cube and then show us that you can solve it, that's worth a gift card. So welcome, Jojo. I just I saw your name here. I hope you heard that full announcement, but we're giving gift cards for solving our puzzles. We are looking and have been looking at ways to slice cubes. What do we think? Is it possible to make a triangle by cutting a slice of a cube? Well, that we figured out that the answer was yes. But could you do it where it cuts across three edges that don't meet at one point? And so maybe this edge, and this edge, like three edges across the top. Could we get a triangle out of those three edges? Or an edge, an opposite edge, and, something like that. And why or why not? Showing that it's possible to get a shape, like showing that it's possible to get a triangle, you just have to give a prescription or you can just show with the rubber band. So that's relatively easy. Showing that something's not possible is a little bit trickier. If you're trying to talk, you need to unmute. I don't think I'm exactly going to give gift cards for turning on your camera and showing your cube, but I will encourage you to shine your camera on your cube and your rubber band. Share that with us. By the way, Nina and Sam, you can earn gift cards as well. But if you send me something, solution to a puzzle, you got to tell me an address of where to send the gift card. Make sure that it's kosher with your parents to share your address and so on. Let me give an argument about this, and I'll give some more terminology. Let's imagine we are going to get, so where are straight sides going to come from when we cut? The place where a straight side is going to come from is when the knife comes through and when it intersects one of the faces of a cube. Two planes intersect in a line. So I could get a straight side that cuts across a face hitting two edges. Where do corners come from? Corners are going to come when I get two sides that meet. And so a corner on our cut is going to come when we hit an edge. So since a triangle has three corners, we have to hit at least one edge. If I'm hitting one edge, then coming out of that edge, like I have on the top, the line comes across, it's going to hit another corner of that face, another edge of that face, which gives me another corner of the triangle. If I want my two lines not to meet at a point, well, once I hit this line, I couldn't hit the line on this side. The only other choice would be to be opposite. And so that gives me two corners for a triangle. Now, in order to get the third corner for the triangle, that has to extend the edge on this side and the edge on this side. And the only way that's going to work is if the one on my right, the one I'm wiggling here, and the one I'm wiggling here would have to meet at a common edge. But this face is opposite of this face. Those faces don't intersect. They don't share an edge. There's no way that that can happen. Does that make sense? It means that there's no way to make a triangle by having two of the corners go across opposite edges. It means that two of the corners of the triangle have to be edges that meet, and that works for any two corners. So the only way you can make a triangle is by cutting across the corner of the cube. And that in itself has some interesting consequences because, for instance, This is not a cut because I'm not getting a straight face. If I cut in the plane, I would just get a straight copy. I would get the whole square here. Just because I can hold the rubber band like that, that's not cutting with a knife. If I was cutting through a knife in this region, in fact, it would pick up this whole square. I have to move slightly off a little bit. And you see what happens. So right here, if I'm holding it like this, right on this face, this is a right angle. As I pull this back, what happens to that angle? That angle, if you look at the sides there, is it getting bigger or smaller? So I start here and look at the angle where my moving finger is. Is that angle getting bigger or smaller as I pull it back? You can put it in the chat. You could even do it with a one key, B for bigger, S for smaller. I know in the morning it's rough to motivate, but grab a cup of coffee, caffeinate, B or S. Naomi, did you just solve your cube? I thought I saw that scrambled. That's pretty awesome.
We solved it.
That's awesome. So it didn't take too long to earn a gift card. I think I said scramble it and solve it, and we give you a gift card. So bigger or smaller? Come on, it doesn't hurt. I can't drop you into a pit. Not seeing the current. No, I'm seeing all of it. Tell me, look at this angle. Is that angle between those two sides getting bigger or smaller?
Bigger.
Wait, so here, look at how wide it is. And I'm looking at this angle up here. Now I pull this back. The rubber band, the triangle is getting bigger, but are the two sides getting closer together or further apart when I do this? So a small angle, let me go to the screen share and draw a picture here. Let's click that. So what we were talking about is we had one point here, and we had sort of an edge here and an edge here. Actually, maybe the right way to do it is we had, instead of a point there, forget that. Let's put a point up here and a point up here. This is like a slingshot. In fact, let's draw like a slingshot. I like that. So here's a slingshot, which you could make with the rubber band, right? And so I could start holding the pebble and the rubber band like that in this first position. And I get this one purple angle. Then I could pull it back like this. And when I pull it back like that, I get a different picture. And I want to know, is this green angle bigger or smaller than that purple angle? Just to get a sense of this, we can do it in a discrete setting. Or I could have a purple angle there. And I could have a green angle here. In fact, with that green angle, I could have another copy of that green angle here. These two angles are congruent, right, like that, because there's a reflection in this silver mirror, like in the Khajiit, that takes the one angle and sends it over to the other. So it means that two of these greens fit inside the purple, so the green is equal to half of the purple. So green is less than purple. So when I'm comparing the sizes of angles, I'm not looking at the length of the edges. I'm looking at the space or the size of the arc. If I make the length along the side there the same as I need to approximate that length this way. So that is congruent to that. And that is congruent to that. And now I can compare the sides that we get, like this orange cutting across there, to this red across here. This red is smaller than this orange. I have to make things the same size because if we had an angle, comparing the sizes of an angle, like this, I could get any size I wanted, right? I could have a tiny yellow piece here. I could have a green piece here, a blue piece here, a purple piece here. Which piece of distance is a way of measuring the size of the angle. There's no coherent way to say how big the angle is unless I mark off and say, let's go exactly one square this way. If we decide to go one square that way, then that distance measures the size of the angle. And so I'll turn off my screen share again. And flip this down to the cube. I'll give some one more definition, probably bring this to a, so what happens is this is just like the slingshot, right? This is like the slingshot. I've got this here, I got the penny here, I pull it back. And so what's happening to the angle? What's happening to the angle is the distance between the parts I'm holding is staying the same. As I pull the penny back, the whole triangle gets bigger. If I want to make the distance the same in this triangle, so the distance between the penny and my thumb, one finger, the same when I pull it back, if I go that distance, I'd look at the distance between these 2 points that were one finger away, which are closer together than I see here. So when I pull the slingshot back, the angle gets smaller. The relevance of that to the cube is that if this was all the way straight, which wouldn't cut a triangle because it would go all the way across, it would be a right angle. In order to get a triangle, I have to pull it back a little bit. That makes the angle smaller than a right angle. And if I continue pulling it back, it continues to get smaller and smaller and smaller. So since the only way you can cut a triangle is when you cut 3 edges of the cube that touch, And whenever you pull the side back, the angle gets smaller than a 90 degrees. The only angles you can get are acute angles. So these cute little angles, sorry for the horrible dad jokes, but an acute angle equals, well, it's like a small kid, it's cute. It's smaller than a right angle. Means it could fit inside a right angle is another way of saying it. So this is a right angle, and this is an acute angle. An acute triangle equals all angles are acute. And if I'm doing that, I might as well say obtuse equals all larger than a right angle. And an example is like this. That angle, a right angle sits inside it, is obtuse. An obtuse triangle equals at least, in fact, it'll be exactly one obtuse angle. So that's an obtuse triangle. And what we just argued is that all of the triangles on the cube, all cube-sized triangles, are acute. Let me end by telling you one definition with a couple of pictures. Oh, that's bad. This is not convex. So something is not convex if you can draw 2 points in it so that the line segment is not in. So the end points are in. The segment is not. On the convex side, it's just the opposite. Namely, anytime you pick 2 points in the region, if you draw the line segment, that whole line segment is going to be in there. And one of the features convex shapes have is if you intersect 2 convex shapes, you get another one. A cube has the interesting feature that anytime you pick 2 points in a cube, like that point and that point, you're not going to see this because I'm not sharing my screen. Yeah, it's sort of there. I'm sharing my screen and not my video. Stop screen share and come here. So I tried to show you that if I take any 2 points inside the cube and I join a line segment between them, that whole line segment will be in the cube. So a cube is convex. And so that should help you decide whether you could slice a cube and get a non-convex shape. I've taken my time. I don't know if there are questions people have about this session. There are, I'll show you again, a whole number of questions that we did not resolve about cube slices. If you finish a majority of these, and if you don't know what some of these shapes are, you could Google or ask, that's worth a gift card. And so we were able to construct a square, a rectangle, a triangle, an acute triangle. We said that it's not possible to make an obtuse triangle. It's not possible to make a right triangle. So with that said, I'm not sharing my screen. How brilliant can we be? Not very, right? So in this session, we showed that yes, you could make a square. You could make a rectangle. You could make a rectangle that's not a square, a triangle. You could make an acute triangle. You could not make an obtuse triangle. You could not make a right triangle. So what about an equilateral triangle, parallelogram, a trapezoid, a rhombus, a pentagon, a regular pentagon? Try to make these shapes with rubber bands. If you make them, take pictures. You could text them to my phone if you like, or email them to me. If you do a good chunk of these things, that's worth a gift card. That said, I'll flash to the schedule. We're on Thursday, 9:45 Mountain Time now. We'll take a break at 10:30. Alex will help you work on solving your Rubiks Cube. If you know how to do it, you can watch and sort of show off, practice your juggling, maybe do 2 cubes, or try doing it fast. If you haven't got it yet, he'll help out and give more hints. And you can share your cameras. So have a great break.